Hi, in this video, we'll see some more examples on static indeterminacy of truss, which will be more interesting. So let's directly begin with this first example, what we see here. We have a truss which contains 19 members in this. Number of joints is equal to 11 here and number of reactions equal to 6. Why 6? Because at support 1, 11, I mean at node 1, 11 and node 8, we have 3 pin supports. Each will offer 2 reactions and hence 2 plus 2 plus 2, which gives you a value of 6 here. If we want to see what is the overall indeterminacy, we can use this formula m plus r minus 2j, which gives you a value of 3 here. And in order to categorize it as external and internal, we can use this formula for SES r minus 3. R is 6 here, so 6 minus 3 will give you a value of 3 here. And similarly, to determine the internal indeterminacy, we can use this formula, which we are already aware of, which results in a value of 0. So what does this indicate? It says that the external indeterminacy is 3 and the internal indeterminacy is 0 here. All right. But is it so? No. Okay. So this is not true. The answer is no. Why? If we have a basic observation about what is happening here in this particular panel 2, 3, 9, 10, we can see that probably one extra member is there, which means there is an internal indeterminacy here in this particular panel. In all other panels, such as this, and this, we see only triangulations. Okay, so that is an indication that probably there is an internal indeterminacy because of the presence of one or two extra members. Fine. So we will see why this happens so in this case. Now to do that, we have to understand what is happening here at this particular number. Fine, that connects node or joint 10 and 11. Okay, so if we cut across like this and draw the free body diagram for this particular portion, this is what we see here, wherein we see that the force in this number is represented by this F10 11, which connects joints 10 and 11. And then the support reactions that develop at this joint 11 are indicated by H11 and V11. Fine. So what is important here to observe is this number force is collinear with this horizontal reaction H11. Okay, I mean H11. Therefore, this will be equilibrated, but there is nothing to equilibrate this particular force V11. Fine. Therefore, you can see that this is always going to be 0. All right. So if we consider all the support reactions such as that develop at joint 1, joint 11, and joint 8, out of these 6 support reactions, only 5 are unknown because this support reaction is always known to be 0. Fine. So I have summarized here as the support reactions at joint 1, 8, and 11 here. I didn't give 6 of them. I am just indicating only 5 of them because one among them is 0 as I have just told. Fine. So now out of these 5 support reactions, 3 can be determined using equilibrium equations such as sigma fx equal to 0, sigma fy equal to 0, and sigma mz equal to 0, as we know, for the entire system. Okay, that means out of these 5 support reactions, only 2 among them can't be determined solely using the equations of equilibrium. Therefore, I would say the external indeterminacy is 2 in this case. All right. But we have earlier seen that this value for the overall indeterminacy by mistake or by taking the number of reactions as 6 gave a value of 3. All right, and moreover, I said that earlier with our basic observation, this panel is probably containing one more extra number. So we also need to check what is the internal indeterminacy in this case. Right? So we see that the external indeterminacy is 2, all right, and the formula gave us a value of 3, which means probably one internal indeterminacy exists, and this is in this particular panel itself. Fine. So one can remove this particular number 3 connecting joints 3 and 10 or the number connecting joints 2 and 9. Okay, if we do so, even then we get a truss which is still stable. All right. Therefore, What we need to understand here is just with the formula, we may not always get a proper representation of what it actually is. Okay, so therefore, in this particular problem, the external indeterminacy is 2, and then the internal indeterminacy is 1. Fine, we will now move on to the next problem. In the second problem, we have the number of numbers 19, number of support reactions 3, and the number of joints equal to 11. As this is a simply supported system, we can directly say that the external indeterminacy doesn't exist in this case. And then if we use the formula m is equal to, SI equal to m minus 2j plus 3, we see that the internal indeterminacy is 0. So it seems that this is determinate, but we also need to check what is it about the stability. All right, so if we do so, what we can understand is if we apply any load at this particular roller support, such as this, that's what I am indicating here. What is going to happen is this particular joint will undergo a movement like this. That means this number will deform. I can't say deform. This number will change its shape like this, as indicated in gray. And overall, what happens is this particular entire part of truss with this particular number connecting joint. I didn't mention a joint. This number along with this remaining part of the truss will undergo a rigid body rotation about this joint end. Okay, so this rotates about joint end, therefore this particular configuration is going to be unstable. All right. So even though the formula says that everything is fine and it is determinate, but actually it is unstable because of what I have explained here. So in order to overcome this particular problem, what one can do is either this roller support has to be a pin support as we have seen in the first problem. You can see that this is a pin support here in the first problem. Okay, so one can convert this into a pin support. Otherwise, what one can do is one can think of connecting these two joints using a horizontal number, vertical number, because of the orientation what we look at. So doing so will help us overcome that issue. So that's what we are seeing here in this third problem, where we have introduced an additional number connecting the joints 1 and 11. Right? So we'll just see this one more problem. Here we see that the number of numbers equal to 20, the number of support reactions equal to 3, and the number of joints equal to 11. One can check that. Here, if we use the formula for external indeterminacy, we can just make an observation that this is simply support system. So directly we can say the external indeterminacy doesn't exist. If you use the formula for internal indeterminacy, we will get a value of 1. Okay, even with the proper observation, we can see that one excess number seems to be there in this panel. Fine. So that is true as well. Because of the surplus number present in this particular panel, we can say the internal indeterminacy is 1. So we can remove this particular number. Otherwise, we can remove this particular number. The resulting configuration will still be stable. Okay, so in this case, the internal indeterminacy is 1. All right. Why can't we remove the number from any other panel such as this? Because if we remove this particular number, let's say, it will cause instability here in this particular panel. Okay, so we can't remove the number anywhere else but in this particular panel 4, 5, 7, 8. All right. So which means the external indeterminacy is 0 in this case, internal indeterminacy is 1. And what about stability? This particular configuration is going to be stable because of the addition of this particular number, as I have already mentioned. Okay, so addition of number connecting joint 111 renders stability to this particular configuration. Therefore, the entire truss in this case is stable and then is indeterminate due to the presence of one additional number. That's all we wanted to discuss through these examples. So the overall take-home message here is we can't just rely blindly on the formula. The formula helps, but not always. So we need to make a proper inspection about the way in which the supports are arranged. Also, we need to see which of the unknowns are really not known and which are really known. And apart from that, we also need to the way in which the truss numbers are configured. All right. Thank you for the patient listening.